Activity 19.4. So you need 3 segments of nichrome wire of length 1 meter having different cross-sectional area. So a 1 meter length of a nichrome wire having different cross-sectional areas, and a copper wire segment and several segments of iron wires with the same length as the nichrome wires and having a cross-sectional area equal to the nichrome wire with the lowest cross-sectional area. So you need 3 segments of nichrome wire of a length of 1 meter having different cross-sectional areas. So in that the length is constant, the cross-sectional areas are different, and then you need a copper wire. Then several segments of iron wires with the same length as the nichrome wire. That means you need to have 1 meter length of iron wires having a cross-sectional area equal to the nichrome wire. Nichrome wire which has the lowest cross-sectional area. So 3 nichrome wires having the same length, different cross-sectional areas, and then the copper wire and iron wire having the same length as the 1 meter, but the cross-sectional area is equal to the nichrome wire with the lowest cross-sectional area. And 2 dry cells, an ammeter, a switch, a board of wood with a length of about 1 meter and a breadth of about 26. So you have to connect the wires like this. So look at your book. Right? So the first wire is the nichrome wire with the largest cross-sectional area. And the second one is the nichrome wire with the medium cross-sectional area. And the third one is the nichrome wire with the smallest cross-sectional area. And the fourth one is the thin copper wire. And the fifth one is the thin iron wire which has the same cross-sectional area of the lowest, the nichrome wire which has the lowest cross-sectional area. And 6 and 7 iron wires are different in their sizes, lengths. So you need to connect, you need to set up the circuit like this, and you need to connect the wire so you have to connect the circuit and connect the terminal X to the end of each conductor at a time. So in the first incident, in the first case, you have to connect the X to the first wire. Then you have to get the reading. Then the second wire. You have to connect the wire X position to the second wire. Then you have to get the reading. Likewise, we have to get the readings with all 7 wires. So you may observe that the first three wires, actually the first three wires are made out of nichrome, so the same metal, but their cross-sectional areas are different. So the cross-sectional area which has the wire which has the lowest cross-sectional area will have the highest resistance. Then the cross-sectional area, which is the second question, second large cross-sectional area will have the highest resistance. Then when you compare it with the iron wire, right? Iron, the resistance may be low. I mean, the iron wire, which has the same cross-sectional area as the of the nichrome wire, having the lowest cross-sectional area, the resistance will be lower than that of the nichrome wire. And the copper will have the highest, lowest resistance, the copper wire. So why is that? In the first three incidents, the cross-sectional area, only the cross-sectional areas vary. So as I mentioned earlier, when the cross-sectional area is large, the resistance is low. And depending on the metal also, the resistance vary. The copper has the highest it is a very good conductor, so its resistance is very low than the nichrome. Nichrome has a very high resistance. And the length, if you look at the three iron wires, they are different, and their lengths are different to each other. So the wire which has the lowest length will have the lowest resistance. So that is so you can read it. And you can read about, then I'll move on to the resistors. In order to control the water flow through a tube, a tap can be used. So actually that is given in, I'm reading your book, right? So what is done here is the use of an obstacle to control the water flow. So that's a resistor. So you put a small gadget to control the current. So that those are called resistors. So for some circuits, you need to decrease the current that flows through that circuit. So that you need to have a resistor. And for some conductors, you have to increase the current flow. For that also, you can use resistors. So you can look at that activity 19.5. It's a very simple activity. And then I'll move on to the type of resistors. There are three types of resistors. The first one is the fixed value resistors, and the second one is variable resistors, and the third one is light dependent resistors. So the first one is fixed value resistors. So in these resistors, you cannot change the resistance, right? But depending on thin films of carbon on insulators or by binding a material with high resistance, materials like nichrome, resistors having various values for the resistors are fabricated. So their resistance is constant. They cannot be changed. Right? So the symbol of a resistor is this. resistance, right? So this symbol differs types depending on type of resistance. These are fixed resistors, so their value cannot be changed. And for these resistors, there is a resistor color code. There is a color code for these resistors. So you may actually when you take this type of resistor, you may have you can see several color bands, right? So each color band represents a value. So look at your book, figure 19.27. The band which is at the right hand side, which is at your right hand side, it's the tolerance interval. And the next one is the index of the 10th power, 1's place, and the next one is 10's place. So for the tolerance value, it's a fixed. If it is brown, actually it's a percentage. So if it is brown, it's 1%. If it is red, it's 2%, plus or minus 2%. That means that it can be if the resistance is 100, it can be either 101 or 99. Red is 2%, gold is 5%, and silver is 10%. No fourth color band represents 20%. Right? And the other if it is black, it will be 10 to the power 0, that is 1. And if it is brown, it's 10 to the power 1, that is 10. And if it is red, it's 10 to the power 2. So you may, you can understand this well if I do an example. So we'll see.